points. The new piece that we're going to look at is the correlation that you may not have done before. First thing on here are a couple definitions. Actually, I don't know that I even printed those on your handout because I was saving space, but you don't need to write all of this. We just need to know the difference between a response and an explanatory variable. So just jot this down on your notes handout there if you need to. So a response is a variable whose value can be explained by the explanatory. All right, if you're just writing this down, really all you need to know is which one is X and which one is Y. So if I were writing it down, I probably wouldn't write any of the words. I would just say response variable is this and explanatory is that. So if you're looking at this, response is a variable whose value can be explained by the explanatory. So which one do you think would be the X? The X comes first. That's your explanatory. The response is the one we're measuring based off that. So when we graph a scatter plot, your explanatory variable is your X, so it goes on the horizontal axis. Your response variable is your Y, so it goes on the vertical axis. That's what you need to know from that. So if I look at an example, the data shown are based on a study for drilling rock. Researchers want to determine whether the time it takes to dry drill a distance of 5 feet in rock increases with the depth at which the drilling begins. Okay, so it's got my explanatory variable, my response variable. All I'm asking is a scatter diagram. Now you guys can plot things by hand, but let's learn how to do the calculator. Okay, if I asked you to actually draw and plot all those points, could you? They're just ordered pairs, so you would have to make your scale. If you go to your calculator, first thing you need to do is enter all of this in your L1 and L2. So your L1 is your X, your L2 is your Y. Make sure to clear out anything that you already have there. Then if you go to second y equals, that takes us into our stat plot. Go into plot 1, turn it on, and then which of those looks like a scatter plot? The first one, a bunch of dots. Okay, so select the first one, and then let's go zoom number 9. That will zoom to where our stuff is. And so we get a graph like that. On the homework, there are several. I think I'm going to have you do one scatter plot by hand that has just a few points. The rest of them are on the calculator. Please, something that I need to stress with you guys, you're not showing me enough work, especially when it comes to like tests and quizzes. You're doing things on your calculator and I don't know how you got your answer, so I don't know why you missed what you missed. So if you're doing this on your calculator, just draw me a really rough sketch so I know what you're looking at, so I can tell if you're even looking at the right thing or not. Any questions about how to get that plot? Reminds me, do I have quizzes to hand back to you guys, or did I already give you? then we can talk about this correlation here. We can have positive and negative correlation. We can have strong and weak correlation. We are focusing on linear right now. So these first two, the top two, these are both just linear. The first one would be positive or negative. Positive because it's increasing. The second one is a negative. Now, down here, they're not linear. There's definitely a pattern there. Just because it's not a line doesn't mean that there's no relationship at all. You know, the first one, what does that look like? A parabola, you know, an x squared. So it's got a relation, it's just not linear. The second one, there's a clear pattern. So again, there is a relationship, it's just not linear. The third one, you could maybe make an argument that it's pretty flat, but there's really not much of a relationship there. So we are going to be looking today at if we have relationships or not. And to do that, we have what's called a linear correlation coefficient in this beautiful formula, which we all know we don't have to memorize any formulas. If you look on your formula sheet, the very first thing in chapter 4 is this formula. Okay. This funny looking E thing, that means a sum, so we're going to add up. X sub I just means a particular X value. What's X bar? The mean of your X's. What's S? Standard deviation of your X's. Same thing with your Y's, so we'll have to calculate all those, multiply them together, add them up. Divide by n minus 1. What's n? Number of points. So this again, kind of like standard deviation. It's time consuming. I'll ask you to do maybe one by hand. After that, we'll learn how to do them on the calculator. Okay? So let's look at an example. Just a few properties about this before we go any further. You will always get something between -1 and 1. If it's close to a -1, that's a really strong negative relationship. +1 is a strong positive. This is only for linear. So getting an R of 0.1, well, that's not close to +1, so it doesn't tell me there's a linear relationship, but does it mean there isn't any type of relationship? No, it could be quadratic or something like that. This only measures the linear. Anything close to 0, then we just say there is no relationship there. It is not resistant. That means if you have one weird value, it will have a huge impact on this. So outliers make a big difference when we're calculating our R. This is just showing you some more examples. This is like a perfect R equals 1. This one, the R was 0.9, so it's still a pretty strong positive. This is an R of 0.4. You can still see it's positive, but the points are a lot more spread out. And this is your perfect -1, kind of showing you those. The last two, these are when R is close to 0. The first one we see there is no relationship at all. The second one, we still get an R close to 0, but there really is a pattern there. Okay, so we're going to do a linear correlation coefficient. For this, we need some information. We need X bar, standard deviation of X, Y bar, standard deviation of Y. We can do all those things by hand, but that is extremely time consuming, isn't it? So why don't we at least use the calculator to calculate those things for us? So if I go to Stat, we're going to enter those things. And L1 and L2. And then we go to stat, calculate, what do I want? Two variable statistics. You should just be able to enter through this screen. And I get everything I need. So my X bar is a 4, standard deviation of X, 2.44949, keeping it. Let's just, yeah, I guess I'll go with that. Y bar was 10, standard deviation of Y, 5.612486. So we are going to make a table. I'm going to make one for the X portion, one column for the X portion of my formula, one column for the Y portion, and one for the product. Okay, so I'm going to write out just one of these to show you what I'm going to plug in my calculator. So for instance, for my first X, my X sub I is a 1. My X bar is a 4, so I'd put that in parentheses, divided by the standard deviation of X. And let's just go to 4 decimal places. I get negative 1.2247. If you hit second enter, you can just bring this back and change your 1 to a 3 for the next one. We have a 3 twice. 6 gives me 'I entered all of those. You guys know where I'm getting my numbers? So for the Y column, my first Y is 18. The mean of my Y's was 10, divided by standard deviation. Again, if you type in the full thing, then you can just hit second enter and change your Y's as you go through. Then what do I need to do with those things? Multiply them. So for the first one, I just take my negative 1.22 number times my 1.4 number. Can I just write down what you're going to get for all of those? You guys are just multiplying. No, it's not. Sorry. Okay. So the formula that we're using here says we have those products. We've done that. Now we need the sum of all of them. So I need to add up this column. This is where, like, I'm starting to notice issues on your quizzes. You guys are adding and doing those things, but you're not writing down any of the numbers you're getting. So you may make this table and then you're not showing me any more work until your final answer. And if you make a mistake along the way, I don't know what you're doing wrong. So please show me more. Show me every step. So when I add those up, I get a negative 3.7823. So R says you take that sum and I divide by n minus 1. What's my n? How many points do we have? 5 minus 1. So you're going to take that and divide by 4. And I get an R of negative 0.9456. Okay, so what do you think that tells me? Is there a relationship there? Yes. What kind of relationship? A negative linear relationship. Okay, I want to show you how to do this completely on your calculator now. You do have to do one thing first. Once we do this, it should stay there, but we have to turn something on in our calculator. So we need to go into second, and then if you hit 0, it takes us into our catalog. You need to scroll down to the D's. We need diagnostic on. So second 0, and then we're just scrolling forever. Okay, and you get diagnostic on. Hit enter. And it says diagnostic on your screen. Hit enter one more time and it should say done. Now we've turned that feature on our calculator. Unless you reset your calculator, it won't go away. So it should be there. You won't have to do this every time. Now I want to go to stat, calculate. What?
Whenever you push enter, does it change the thing? Can you see if I did this right? I don't know how to explain it. Because this doesn't.
You hit diagnostic off instead of diagnostic on. So you go down, it's the one right below diagnostic off. Okay, so if we go to stat calculate, we are trying to find if there's a linear relationship. So we are going to choose number 4, linear regression. Now as long as you're using L1 and L2, you should just be able to enter through that screen. And it should bring up this information. If you didn't have your diagnostic on, it would give you A and B, but it wouldn't have any information about R. Did you get it?
No, I don't know.
Okay. Did you get your diagnostic?
Yeah.
Okay. Stat, calculate, regression. Okay. If you look at the R, is that the same R value we had? Yes. So we don't have to do it by hand every time. Again, one problem on your homework I went by hand, otherwise we're just doing it on here. It gives you the y equals ax plus b. That's your line of best fit. So it gives you the slope and y-intercept there. And we will graph those occasionally as well. Any questions about that? So we need to know how close to 1 does R have to be before we can say it's a linear relationship? You know, 0.94, we're pretty confident. But what if it were 0.6? Is that good enough to say it's linear or not? And it actually depends on how big your sample is. So we have some guidelines for helping determine that. If we look at this, what we're going to do is look at the absolute value of it, and we're going to use table 2. So go to your formula packet. It's the back of the second sheet, kind of halfway down. There's table 2. So this tells you an N and then a CV, a critical value. If the absolute value of your R is bigger than your critical value, then it would be considered linear. So for instance, we were looking at a sample of size 5, and the critical value is 0.878. So as long as my R had an absolute value bigger than 0.878, it's considered linear. Does that make sense? Everybody find that? So let's do, well, I guess I kind of just did that one for you, didn't I? Whether a linear relationship exists in example 3. So that's the example we just did. The cutoff, like I just said, was 0.878. So if we did the absolute value of negative 0.9456, and again, we do the absolute value because the negative just tells me it's a negative relationship. That is bigger than whatever I said, 878. So it is linear. Would it be a positive or a negative linear relationship? A negative linear, because we had a negative R value. The next thing, I put a definition on your sheet, but before I talk about that, I put a question up to kind of motivate it. So according to data obtained from the Statistical Abstract of the United States, the correlation between the percentage of the female population with a bachelor's degree and the percentage of births to unmarried mothers since 1990 is 0.94. So does this mean that a higher percentage of females with a bachelor's degree causes a higher percentage of births to unmarried mothers? Is that what it means? That if more females get a college degree, that there will be more births to unmarried mothers? No, that would have, whether or not you have your degree has nothing to do with the other. So just because the R is high, does that mean one causes the other? No. Correlation does not mean causation. Just because there's a relationship doesn't mean one causes the other. We have to consider things like lurking variables. That's something that might be related to both of those and has an impact on both. For example, ice cream sales and crime rates have a very high correlation. When crime rates go up, ice cream sales go up. Does that mean that we should shut down the ice cream shops to make our crime rates go down? No. What might be a lurking variable there? Bucket Costa. Do you know that the hotter it is, the higher the crime rates are? And the hotter it is, wouldn't people be more likely to buy ice cream? Now, that's not saying that's what caused both of those, but that is a lurking variable that would take into account. So just be careful. Don't say one is causing the other. There's a relation, but we don't know what it is, because there are other things that could be factoring in. Okay, so let's look at this example. Because colas tend to replace healthier beverages and colas contain caffeine, researchers want to know whether it was associated with lower bone mineral density in women. So the table lists how many sodas per week, along with the bone density for 15 women. If I look at the next slide, I went ahead and just graphed the scatter plot for you. You could put them in your calculator and get a graph. But if I'm looking at this, and if I calculated it, I got an R of negative 0.806. So first of all, without reading my little blurb, let's see if that's significant. Look at your table 2. I told you there were 15 women, so you go to n equals 15. What's my critical value? 0.514. So is my R, the absolute value of my R, greater than 0.514? Yes. So that means there is a relationship. Is it a positive or a negative? Negative. R was negative, so there is a negative linear relationship here. Okay, so I can conclude that the number of sodas you drink per week and your bone density are related. Can I say that drinking soda lowers your bone density? No. Why? What could happen? What else could be going on? There could be a lurking variable. Maybe the people that drink a lot of soda have a lower bone density because they're not drinking milk. Is it because of the soda? Maybe indirectly, but it's more that they're lacking something else in their diet. Not necessarily the soda itself, but what else they're lacking. So we can't say that one caused the other, we can just say that they're related. All right. Any questions? So that is my stopping point. That's the end of this section. So our homework, page 190, 10 through 18 even, 26 and 28, 44. 26 and 28, do both of those on the calculator, but please draw me just a really rough sketch so I know what you're looking at. I think 1 through, like number 18, I believe, is one that it asks you to do it by hand. So 18 is by hand, but the others are on your calculator.